Everything you were taught about matter is wrong. Not partially wrong, not slightly outdated, fundamentally, completely, and deliberately oversimplified to the point of deception. And today, that comfortable lie ends. Your teachers told you that matter is one thing and energy is another. Matter is what you can touch: a rock, a coin, a table. Energy is what makes things move: fire, electricity, heat. Clean categories. Simple boxes, easy for a young brain to organize and accept. But those categories are a useful fiction, a mental shortcut that kept you from asking the question that changes everything. What is matter actually made of at its deepest level? Because the honest answer does not describe something solid, stable, or separate from energy at all. It describes something that will make you look at your own hand differently for the rest of your life. Hold that thought for a moment and try this instead. Imagine pinching exactly half a gram of matter between your thumb and index finger. Half a gram is smaller than a grain of rice. You could drop it on a table and barely hear it land. It looks harmless, inert, almost meaningless. But hidden inside that half gram is a secret so extreme that physics took decades to fully confront it. If someone could break open the deepest structure of that tiny piece of matter all at once and release everything trapped inside, the resulting explosion would carry the destructive power of more than 10,000 tons of dynamite. An entire city gone in a fraction of a second from something you could barely feel between your fingers. That is not an exaggeration. That is the strict mathematical output of one of the most verified equations in the history of science, the principle stating that energy equals mass multiplied by the speed of light squared. And understanding why that equation is true, step by step, without shortcuts or tricks, is what this entire exploration is about. Start with what you believe you know about solid objects. Touch the nearest surface. It feels firm, continuous, real. Your senses are reporting a consistent and trustworthy picture of the world. They are lying to you. If you could zoom into the true scale of that surface, if your vision could penetrate down to the actual texture of matter, you would discover that the table in front of you is almost entirely empty space. Roughly 99% of every atom is nothing, a vacuum, an immense silent void. In the center of that void sits something extraordinarily small and extraordinarily dense, the atomic nucleus. To grasp the scale properly, imagine an atom expanded to the size of a massive football stadium. The nucleus sitting at the center of that stadium would be a single grain of sand. Everything else, the entire stadium, is the space through which invisible, nearly weightless particles called electrons orbit like ghosts. And yet all the mass, all the weight of every atom in your body, in the ground beneath you, in the burning core of distant stars, is compressed into that single grain of sand at the center. That is where the real story begins. Inside that nucleus are two types of particles: protons, which carry positive electrical charge, and neutrons, which carry no charge. And the moment you truly understand what those protons are doing to each other inside that microscopic space, the fact that matter exists at all becomes the most astonishing thing in the universe. Because according to the most basic rules of electromagnetism, the atomic nucleus should be physically impossible. Think about two magnets with identical poles facing each other. Press them together and feel that invisible wall of repulsion pushing your hands apart. The force is real, measurable, and completely unambiguous. Now scale that same electromagnetic repulsion down to the subatomic level, where dozens of positively charged protons are packed together inside a nucleus smaller than any microscope can directly resolve. Every single proton is repelling every other proton simultaneously with a force that at those distances becomes genuinely monstrous. According to classical physics, an atomic nucleus should explode the instant it forms. The electromagnetic repulsion alone should tear it apart before it has any chance to exist. And yet here you are, listening to this, built entirely from atoms that have held together for billions of years. The nucleus has not exploded. So something else must be operating something powerful enough to overpower one of the fundamental forces of the universe. That something is called the strong nuclear force. It is, without any close competition, the most intense force in all of known physics. It grabs protons and neutrons and compels them to remain together, crushing them against their own explosive impulses with absolute authority. But the strong nuclear force has one critical limitation. It is extraordinarily short range. It only works across distances so tiny that they make an atom look enormous by comparison. Think of it as the most powerful adhesive in existence, but one that only sticks when the surfaces are touching. The moment two particles drift even slightly beyond its microscopic reach, the glue stops working entirely. This creates the precise battlefield condition that makes everything else in this story possible. Inside a small, manageable nucleus like carbon or oxygen, the strong force wins easily. The nucleus is compact enough that the short-range adhesive can grip everything at once, and the electromagnetic repulsion never builds enough pressure to overcome it. These atoms are stable, the prison holds, but nature produces monsters. Enter uranium, specifically the isotope uranium-235. While an oxygen atom has just 8 protons, a uranium-235 nucleus contains 92 protons and 143 neutrons packed together. That is a nucleus so massive, so overcrowded, so structurally stressed that it sits permanently at the absolute edge of what the strong force can maintain. The electromagnetic repulsion does not just push between neighbors inside uranium, it reaches across the entire enormous nucleus. All 92 protons are simultaneously repelling all other 91 protons at once. The total accumulated pressure is immense. Meanwhile, the strong force, with its desperately short range, can only grip immediate neighbors. It cannot reach across the full width of such a gigantic nucleus to hold the distant ends together. The result is a nucleus in a state of chronic structural crisis. It trembles, it vibrates, it deforms continuously like a heavy drop of water on the verge of splitting in two. The war between the two forces has reached a grinding, agonizing standoff, and the entire structure is waiting for the smallest possible disturbance to finally tip the balance. Now here is where human intuition fails completely. You might expect that breaking this already unstable nucleus requires something violent, a particle fire at tremendous speed, a powerful collision, some massive application of force. The reality is precisely the opposite. A fast particle fired at the uranium nucleus will simply pass straight through it without being captured. To actually trigger the collapse, what is needed is something almost absurdly gentle, a single neutron, traveling slowly as a piece of paper drifting through still air. A slow neutron approaching a uranium-235 nucleus does not collide violently with it. It is absorbed by its swallowed whole. The nucleus, already a uranium-235 atom, takes in that extra neutron and becomes uranium-236, an even more grotesquely unstable configuration. That single additional particle is enough to push the entire structure past its breaking point. Picture a thick water balloon being stretched from both ends simultaneously. It elongates, thins at the center, forms a narrow waist. That narrowing is fatal. As the nucleus stretches, the protons at one end move too far from the protons at the other end. The strong nuclear force, with its unforgivingly short range, loses its grip on the distant particles. Its adhesive power fails to bridge the growing gap at the center. And in that precise instant, the electromagnetic repulsion, which has been building pressure from the very beginning, finally wins the war. 92 protons that have been desperately repelling each other suddenly find themselves free of the force that was holding them together. The nucleus tears itself apart. Two smaller nuclei fly outward in opposite directions, propelled by the full fury of electromagnetic repulsion that had been trapped and suppressed until that moment. This violent splitting of the atom is what physics calls nuclear fission. And what has just been described is only the beginning of the true story, because the actual source of the energy released goes far deeper than flying fragments. Here is the question that stopped physicists cold and forced them to rewrite the rules. Take a perfectly precise scale, the most accurate measuring instrument imaginable. Before the fission occurs, weigh the original uranium-235 nucleus plus the neutron that triggered the split. Record that number with perfect precision. Now allow the fission to happen. Collect every single fragment produced. The two smaller nuclei, the 2 or 3 extra neutrons ejected during the split, every particle without exception. Put everything back on the scale. Common sense and the law of conservation of mass, one of the foundational principles of classical physics, both insist that the total weight must be identical. Break a ceramic plate and weigh all the pieces. They match the original plate exactly. But the quantum scale tells a different story. The fragments weigh less than the original nucleus. A tiny fraction, less than 1% of the original mass, has simply vanished from material existence. It is not in the two new nuclei. It is not in the ejected neutrons. It is not hiding anywhere in the physical debris. A measurable quantity of matter has ceased to exist as matter, and physics demands an answer to the question of where it went. The answer is the equation that appears on posters and coffee mugs, and is quoted by millions of people who have never genuinely grasped what it means. Energy equals mass multiplied by the speed of light squared. That missing fraction of mass did not disappear into nothing. It changed identity. It converted directly and instantaneously from matter into pure energy. And the conversion rate written into that equation is what transforms a barely visible fragment of missing mass into something that can erase an entire city from existence. The speed of light in a vacuum is approximately 300,000 kilometers per second, the maximum velocity permitted by the structure of the universe itself. The equation does not merely multiply mass by that number. It multiplies mass by that number squared by 300,000 multiplied by another 300,000. The result is a conversion factor of such astronomical magnitude that even the most infinitesimal amount of missing mass produces an output of energy that belongs to an entirely different category of physical reality. That vanished fraction of mass reappears in the universe as extreme heat, lethal radiation, and a violent release of kinetic energy, all from a single atom. One atom, a particle so small it cannot be seen under the most powerful microscope ever built. The energy released by one fission event is barely enough to move a speck of dust a fraction of a millimeter. It would not warm your fingertip. It would accomplish absolutely nothing on the scale of human experience. But return to the half-gram pinch between your fingers. In that half-gram of uranium, there are not 1 or 2 or even a million atoms. There are hundreds of trillions of uranium nuclei, a number so vast that if you began counting them now, 1 per second, without stopping to sleep, you would die of old age before completing the first millionth of the task. The question then becomes the critical engineering problem at the heart of nuclear weapons physics. Each individual nucleus requires a precise and rare event to trigger its fission, a slow neutron, drifting gently through the right location at the right moment. In ordinary conditions, free slow neutrons almost never exist. So how is it possible to force hundreds of trillions of unstable nuclei to break apart simultaneously? The answer hides inside the atom itself, specifically in what happens during that first fission event. When a uranium-235 nucleus splits, it does not only divide and release energy. It ejects 2 or 3 free neutrons as part of the debris. The atom provides its own ammunition for the next round of destruction. Those ejected neutrons can theoretically trigger the fission of neighboring uranium nuclei, which then eject their own neutrons, which trigger further fissions in an accelerating chain. But there is an immediate physical problem. The neutrons produced by fission are not slow. They are born moving at a significant fraction of the speed of light, far too fast to be absorbed by the next uranium nucleus they encounter. According to the same physics established earlier, these fast neutrons will pass straight through neighboring nuclei without triggering anything. The chain reaction should choke and die in the very instant it begins. In nature, this is exactly what happens. Natural uranium deposits do not spontaneously detonate because the geometry, density, and neutron speeds prevent a sustained chain reaction from ever developing. Nature has its own safety mechanism. Breaking that safety mechanism requires understanding how to change the physical environment of those fast neutrons. The solution is compression, specifically achieving what physicists call critical mass. Surround the uranium with precisely configured conventional explosives and detonate them simultaneously, directing the force inward from all sides at once. The resulting implosion compresses the metal to extreme densities, physically eliminating the vast empty spaces inside the atomic structure. Now the fast neutrons ejected by each fission event cannot escape. Instead of traveling through mostly empty space, they immediately collide with a dense wall of neighboring nuclei packed tightly around them. Each collision slows them slightly. After 3 or 4 forced collisions, a once fast neutron has shed enough velocity to become slow. And the slow neutron, as established, is lethal. It gets absorbed by the next intact nucleus, stretches it, breaks it, and the cycle repeats. The chain reaction ignites. The first nucleus produces 2 useful neutrons. Those 2 break 2 more nuclei, releasing 4 neutrons. 4 become 8. 8 becomes 16. Then 32, 64, 128. The human mind, conditioned by linear thinking and slow daily timescales, imagines this process as gradual. It is not. Each complete generation of this multiplication occurs in 100 millionths of a second. The count leaps from 1 to billions, from billions to trillions. The metal container, the surrounding air, the ground nearby, none of it burns. It is not consumed by fire. It is stripped apart at the subatomic level, losing all its electrons instantly, transforming into a formless bubble of superheated plasma expanding at incomprehensible speed. That plasma sphere begins emitting a flood of X-rays outward into the atmosphere. The cold, dense air surrounding the detonation absorbs this radiation immediately and violently. The air itself ignites. The atmosphere becomes the weapon. A fireball of cosmic proportions forms and expands, consuming oxygen and nitrogen alike. For anyone located kilometers away looking in that direction at the moment of detonation, the first effect arrives in complete silence. Sound travels too slowly to matter at these scales. What arrives first is a pulse of thermal radiation moving at 300,000 kilometers per second, a flash of light so intensely energetic that looking directly at it would cause the fluid inside your eyeballs to boil, before your eyelids could begin to close. The thermal pulse vaporizes paint from buildings, ignites forests at distances measured in kilometers, and carbonizes exposed human skin all in utter silence, before any sound reaches the observer. Then the pressure wave arrives. That expanding plasma sphere pushes the surrounding air outward faster than sound can travel, compressing the atmosphere into a solid wall of extreme pressure moving across the surface of the Earth. This is not a strong wind. It is a physical wall of compressed air that pulverizes reinforced steel, reduces concrete to powder, and tears structures from their foundations with the indifference of pure mathematics. But even after the fireball fades and the pressure wave has finished its work, the destruction is not over. In fact, the most insidious killer is only just beginning to operate silent, invisible, patient, and utterly immune to the passage of time. When the uranium nucleus split into two smaller fragments, those fragments were not ordinary matter. They were deformed, unstable nuclei carrying grotesque quantities of surplus energy and deeply imbalanced ratios of neutrons to protons. Isotopes like strontium-90 and iodine-131 aberrations that do not occur in stable nature, created only by the forced disassembly of heavy atoms. These fragments were hurled skyward by the immense heat of the explosion, mixing with thousands of tons of vaporized earth, pulverized building materials, and combusted debris. As the atmosphere cools, gravity reclaims everything it lofted. It descends back to the surface as a fine, gray, completely silent rain. It looks like dust settling on abandoned furniture. It is radioactive fallout. These unstable isotopes are desperate for equilibrium. Their internal architecture carries more energy than their structure can contain, and the only mechanism the universe offers for releasing that trapped energy is radioactive decay, the continuous ejection of high-energy particles in all directions. Alpha particles, beta particles, gamma rays. These projectiles are completely undetectable by human senses. No smell, no color, no physical sensation at the point of contact. You could breathe contaminated air, drink contaminated water, and your body would register nothing. But inside your cells, a war of annihilation is underway. When a high-energy particle from a decaying isotope passes through biological tissue, it does not simply collide with your cells the way a stone strikes a window. It acts as a microscopic artillery round moving through a densely populated landscape of atoms. The particle carries enough force to tear electrons away from the atoms it passes near a process called ionization. Stripping those electrons fundamentally alters the chemistry of every molecule the particle encounters. And the most vulnerable structure in your entire biology is your DNA. These invisible projectiles physically sever the double helix chains of your genetic code. If the damage is limited, the cell's repair mechanisms attempt reconstruction, but they frequently introduce errors in the process, creating mutations that can lie dormant for years before manifesting as uncontrolled cellular growth. If the radioactive exposure is intense, as it is in the immediate aftermath of a nuclear detonation, the damage to DNA is too extensive and too widespread for repair systems to address. Your cells lose the instructions required for orderly division and renewal. Within hours or days, the lining of your intestines begins breaking down. Your bone marrow stops producing blood cells. Your immune system collapses completely. You remain physically alive while your body systematically dismantles itself from the inside outward, not from poison or infection, but because the quantum mathematics of unstable isotopes has methodically destroyed the molecular architecture of your biology. And unlike the blast and the fireball, this invisible contamination does not end when the event ends. It infiltrates soil, water, and the food chain, persisting in the environment for decades, centuries, and in some cases millennia, accumulating silently through every generation it touches. All of this was waiting, dormant and patient, in that half gram of dark, inert metal resting between your fingers. Every stage of this process follows directly from the same fundamental insight. Matter and energy are not separate categories of existence. Matter is energy in its most compressed, most tightly imprisoned state. The same mathematics that ignites the nuclear furnace at the center of every star, that makes the sun shine and life possible, is the mathematics that can erase everything life has built in less time than it takes a single thought to cross your mind. The universe follows no moral code. It recognizes no exception for human civilization. It only obeys its own quantum and thermodynamic laws with absolute, impartial precision. We decoded those laws, compressed them into metal spheres, and placed them within reach of the same instincts that once determined which rival tribe deserved to survive. If understanding the true architecture of reality, not the comfortable version, but the precise and unfiltered one is what you come here for, subscribe and share this with someone who still believes the world is exactly as solid as it appears. The next deep dive goes further still.